Okay. So, I guess for a couple of years now, everyone keeps asking us, when are you going to support Wayland? When are you going to support this other windowing system? And I guess at some point we decided it's probably not going to stop happening, so we had to try to come up with a way to support all these things without writing 18 new drivers. Gave a lot of thought to that for about 6 months, and I guess I came up with a bunch of different ideas for extensions in EGL to make this easier to support from a driver vendor point of view. So basically came up with these goals. We wanted to have a cross-platform method to discover devices. So like on Linux, you have DRM or something like that to discover devices. With NVIDIA, we have our own internal APIs. We wanted something we could support anywhere without going into operating specific APIs to discover which devices are on the system. Mostly for GPUs, but it could be other devices as well that wanted to interact with GPUs. We wanted a platform-agnostic way to bootstrap an EGL display. So right now, if you want to get an EGL display, you have to have some kind of object to create your EGL display from, something from outside EGL. So I thought it would be better if you could just do that entirely within EGL without having to do anything on the operating system. Most importantly, we wanted to get out of the way of new windowing systems. So I don't know why people keep asking me about this stuff. I shouldn't be in this debate at all. We just make drivers. I don't really care which windowing system people use. I think X is great, but other things could be great too. Something that's been coming up a lot in the context of other stuff is that it's hard to do interop with EGL from non-EGL APIs or even from APIs that are in Kronos but aren't using EGL right now. So for example, if you have an OpenCL device and an EGL display, how do you know if they're actually on the same physical device? And then just as a general guiding principle, want to make something easy to adopt, backwards compatible, and an incremental change that wasn't something you had to go write 10,000 new lines of code in your app for. And didn't want to completely break any existing EGL APIs. So I came up with a bunch of different things that could do this in various parts. The most basic part is having a new top-level object above EGL display. This is sort of hard to do until recently in EGL because EGL display is what everything hangs off of. But recently published were some extensions that allow you to do extension querying and some other stuff before you have an EGL display. I can go into more detail on that later on if people aren't familiar with those, but basically you can get an extension string from EGL just by querying the null display. So that allows you to create extensions that don't require an EGL display, so you can do things like create an object before you have an EGL display. So hence we can put EGL devices that you can create a query before you have an EGL display. So the most basic API is to have some way to enumerate devices on the system. So this would be some function call that takes no arguments, but just says returns all the devices in the system through some memory passed in or something. EGL devices by themselves wouldn't really do much. They're sort of just an identifier. Preferably, they probably wouldn't even have any memory allocated for them. It'd just be some kind of ID that you can pass around, some kind of handle. Because the idea is you want to have these things be able to be around without doing any initialization of your driver. You want to just be able to call down somewhere inside your driver without actually allocating a bunch of data instructions and say, I have these devices that I can support. If you actually want to do something with a device, there should be an API to create an EGL display from an EGL device. So if you're familiar with the recent platform extensions in EGL that allow you to create displays given a particular kind of platform, so you can actually say, I'm giving you this object, it's a display from X11, give me an X11 EGL display, as opposed to having EGL do magic things and say, you gave me some object, I think it's an EGL, I think it's a X display, oh, I was wrong, I'll try something else, maybe it's a GDM device or something else, who knows. Now you can actually say, I'm going to create this kind of display. So you'd have one kind of those extensions that was just an EGL device one. So you can say, here's an EGL device object, give me an EGL display on it. There's no window system associated with that, it's just a handle to the hardware that I can use for other EGL APIs. Even that's kind of invasive, so if you didn't want to go through the trouble of discovering devices on the system, like if you already had some X11 app using EGL, there should be a way to query the EGL device from an existing EGL display. So this wouldn't be very useful for bootstrapping things, but if you wanted to do things like try to associate an EGL display with some other object from another API, you could get the device this way. So I guess when I first proposed this, people were like, what good is an EGL device? What can I do with that? So you can create an EGL display from it, like I said. From there, you can get an EGL context. And then you have two options to actually do rendering on it. You can make current to no surface and create an FBO and render there, in which case you can't put your rendering on the screen directly with that, but you can have an OpenGL texture with content in it that you can use interop with other APIs to do things with, or you could do GL compute types of things. Lets you access the GPU at least, and at least the 3D engine of the GPU. Or you can also create an EGL stream producer surface. I don't know if people are familiar with EGL streams. I think we have the only implementation, so not many people know what they do actually yet, but they're really cool. They basically encapsulate everything about a drawable within an abstract thing that's not a drawable. But then from that object, you can make a drawable in EGL that you can render to like a window or like a Pbuffer. And it just submits the buffers into a queue instead of sending them to some actual place. So instead of sending the buffers on screen, they go into this queue, and then anything can be connected to the other side of that queue and consume those buffers. So once you have an EGL stream, you can make a surface from it, and you can make current to that surface. And by itself, that gives you not much more than the FBO, but it's just another path that will, you can do some other stuff coming up here. So then the hard part always is how do I get my rendering onto the actual screen, some kind of monitor somewhere. So that's always complex, so that should be a separate extension besides EGL device. I don't know a good name for that, but right now it's using the term EGL output. This is an extension that on top of a device enumerates all the output devices on that GPU device. Then people would say, is this going to be a new mode setting API? And everyone hates that, right? But maybe, I don't know. At first I was thinking it definitely shouldn't be a mode setting API, but then once I started looking at it more, it actually made more sense to make it some kind of thing that can do mode setting. Otherwise, you have to deal with things like handling something else doing mode setting and then notifying the EGL output that has changed somehow and tearing everything down. It seems better if you actually have the application that is actually creating the EGL output know when it's going to change itself and handle a lot of stuff internally. So the basic proposed workflow is you somehow create an EGL output. Then if you have to set modes in it, you can set modes in it, do whatever you have to do. Then you create one of these EGL streams and bind it to a context on the producer side, so you're producing content from a EGL context. Then you can bind the EGL output to the consumer side of the stream, so that every time you call swap buffers on the EGL producer side of the stream, it sends a new surface to the EGL output and presents it there on display. And so this is so far that's what you need to do basically to bootstrap a new windowing system on the server side. So if you wanted to implement like a Wayland compositor, you could use those things to enumerate your devices and set up an output. One of the hard parts is always when you create a new EGL, when you create a new rendering system that wants to use EGL on the client side of it, you have to go and modify EGL to have the new native objects in the EGL driver itself. To say, I'm going to send you this object foo, create a foo window out of that, and use it in EGL to do your rendering. So this is actually the first part I thought about, was some kind of way to hook into EGL that rather than make it some kind of driver interface like Mesa has, and we have in our driver stack as well, provide a way to hook back out and call into the native Windows system libraries to make them implement that themselves. So rather than the EGL driver itself containing a bunch of different backends for different windowing systems on the client, just force the new windowing systems to implement that themselves in their own code by redirecting the calls out from EGL back into the native libraries. So then you still have the problem of how does that native library actually go and create some kind of EGL surface for you. It turns out EGL streams are kind of exactly what you want to send content from the server. So if you want to create some window in your new windowing system server somewhere and have it rendered to by a client, you can actually use streams across processes. So you can have the producer side of a stream be in the client process and the consumer side of the stream be in the server process. And then that's serves as the transport mechanism to get all the data from the client application into the display server in the compositor. So what you could do is actually have your native windowing system libraries go and create an EGL stream whenever someone creates an EGL window in their actual application, and use that as the backing store for your EGL window. That's all the slides I had. So, does this sound, no one understand, or is that a terrible idea or good idea, or any feedback?
Almost unrelated, but you mentioned EGL streams quite early on. Do you guys actually see any usage of those?
We talk to people about them, and they say they want to use them, but they can't because there's no implementation besides ours. So.
Okay, yeah, I've mostly had the same reaction to those as I have OpenWF.
As to what?
OpenWF.
Oh, okay.
Yeah.
Yeah, I mean, a lot of people, what we usually hear is, I'm trying to do this, how can I do it in your driver? We say, oh, EGL streams do exactly that. And they say, what are EGL streams? And then we tell them what they are, and that sounds wonderful. We want to use that. We also want to do it on Intel and AMD and Qualcomm. And then we say, you should be able to. It's a KHR extension in Kronos now, but then no one else has bothered to implement it yet, so they don't get much traction.
Yeah, we always seem to end up with images, but then image external tells you that you get linear or nearest filtering, and if you're using them for video, which pretty much everyone using EGL images, then it's a bit pointless.
So how am I? Could you go back to the first-ish slide that had the? Okay.
Forward.
One forward. So you enumerate all the devices. How do you reconcile that with a system with multiple GPUs in? Or do you address that at all? Or is this just is it more like saying EGL provider than EGL device?
So EGL device would be an actual GPU.
Okay.
So if you have multiple GPUs, you have multiple devices. There is a draft of the spec right now that I could send around, but it addresses things like SLI.
Okay.
Like say if you have like an SLI group, that would be one GPU, or a Crossfire group, or whatever it's called. Mm-hmm. Because the API treats it as one GPU. If you have things like Optimus or Prime or whatever, those would probably be two GPUs because they don't really act as like one GPU. It's harder to hide that than it is to hide SLI.
If you had, say you were running under X11 and you could either create EGL that just bangs directly down to the GPU because you're doing mostly off-screen stuff, or you had an EGL that magically translates to GLX and shows up on the screen, would those be different devices? How would you represent that at all in this kind of model?
So that would be one device, because the idea of the EGL device is that wherever like the physical buffers live, that's where you want your device to be.
So the device would be X11, would be the name of would be in the enum somewhere. That's the name of it.
The device would be like GPU 0. And then that same device would be used for, if you're going to do EGL to some local thing, or if you're going to do EGL and pass it through GLX, you still want to know that those would be two different EGL displays, because one would be created against an X11 display and one would be created against the device.
Okay.
But you still want to know they're on the same physical device in case you want to share buffers between them or something like that.
Okay. So that's where the slice between device and display comes in. Okay.
Yeah. I guess an important thing to say is you can't create an EGL display from an EGL device and then use it with, say, Wayland.
Right.
That's not what it's for. You would want to create a Wayland EGL display on the client and a EGL device EGL display on the server, or the compositor. Whatever. Get the terms mixed up.
So once you had an EGL device, you would also want an API to enumerate the list of displays it's possible to create off of it?
Yeah, I haven't decided if that should be if that should be queried from the display, from the device, or that should be queried separately. You could sort of.
Yeah.
melded together somehow. That's one of the things that came up when we were talking about it in Kronos.
Okay.
Is like, do all devices have to support all platforms that are supported by a given driver? Probably not.
Yeah, that
You
seems
probably don't
terrible.
want that. Yeah. So then you need some other thing to enumerate platforms, probably.
If you were trying to do like the Apple thing where you wanted to pick between a software renderer and a hardware renderer, that would probably be another. Would that be an implementation choice as to whether you make that a new GPU or multiple displays on a new device, or multiple displays under the same device, depending on whether they could share objects or not? Does that seem right?
Yeah, I guess, yeah, it depends really on what the functionality of your software driver thing is.
Right.
So if it ends up displaying things on a hardware GPU somewhere or a hardware display device, that would be the device, I guess, that it's associated with. But if it's just something that does everything offline and copies around stuff in shared memory, it's probably just going to be a separate device.
If they both target XPix maps, then they could be under the same device.
Yeah, but in that case, what you're really doing is interop of some sort. You're doing interop between your software driver and some kind of other thing, which is X or a device running X.
Okay. I was thinking between hardware and software clients within the same display, with the same objects.
Yeah, so I had a GLX extension that I was talking about at FOSDEM earlier this year that kind of layered that idea on top of the existing screen display mechanism, where for each screen and display in GLX you could have multiple renderers for it that you could iterate through and then query some things about the renderer and create a context for that specific renderer on that device. So maybe that would be. It seems like there's a way to layer that on top of this kind of mechanism, but yeah. Right.
I guess I kind of think about that sort of like the Optimus or Prime solution, where you have maybe something that looks like the same display, but it's really two devices underneath it. So you probably want to treat it like two devices. And if you somehow got an EGL display talking to both of those backends in the same EGL context or something, that'd be kind of weird, I guess. But maybe displays can have two devices. I don't know. And maybe contexts have a specific device and displays have two devices.
So to select a software renderer, it's not strictly necessary to bind that concept to a device, something that me and Jacob Barkenkratz, what driver does he work on inside of Mesa? It skips my mind at the moment. Okay, he works on a Gallium driver. Okay, so something that we've discussed is using the EGL platform extensions to allow EGL clients to select an EGL display that is a pure software renderer without even this EGL device concept. So the EGL platform extensions allow a client to request an X11 display or a Wayland display or a GBM display or whatever display without considering this device layer of EGL. And it would be really trivial to add another enum to those list of Windows system platforms, which is I want a software renderer display. So we can do that without device. If we use device, maybe we can do even crazier stuff.
One thing I do like about this though is, right now you have to know what kind of EGL you're running on top of. You sort of have to know ahead of time. Well, I'm going to be running EGL on X11, or I'm going to be running EGL on GBM, or on Surface Flinger, or whatever. And I don't think that the platform thing gives me a way to ignore whatever Windows system I'm on. I would like to be able to write an application that doesn't include any native Windows system types and just goes. Particularly because I don't want to, if I want an X server that uses GL to render, I would like not to have to port my X server to every different other Windows system. This is me just being greedy as an X server maintainer.
Yeah, I mean,
this doesn't resize. Like,
yeah. So one of the things about this is that you can't actually the idea is that if you had an EGL display created from an EGL device, it wouldn't actually export any or EGL configs that support rendering to Windows. So you couldn't resize your windows or anything like that. It makes it a lot simpler. That's why I guess having you have mode setting in there. If you don't have mode setting baked into this, then the mode might change out from under you somewhere, and then all of a sudden you have to handle surface resizing. If mode setting is something you have to do explicitly as part of this API, then you know whenever the mode changes, and you have to be responsible for that yourself and tear down your surfaces and recreate them, or somehow handle resizing in your application itself. It allows you to not push events into EGL, which I do not want to do.
So, but the application may not. I don't know. There's some part of that I'm not grokking. Like on my system right now, I can change my window size, and my app isn't doing that. So it's got to know somehow that something happened.
So yeah, I mean that's on the client side, right? You have a client application, so that would have an EGL display. That's probably not an EGL device. It'd be an EGL display based on top of some kind of Windows Server display, a different platform. This is only for rendering to either off-screen surfaces, or if you're using EGL up at some full-screen surface.
Okay.
Right. And then maybe underneath those EGL displays, since they're redirected to some kind of pseudo EGL implementation, could be implemented on top of an EGL device, but you'd have some library in between doing all the magic to go and resize those objects when you needed them to be.
Right.
And they'd all be essentially off-screen surfaces. Only the compositor would know that they're actually on screen.
Point of trivia, is it legal to implement a EGL config that actually doesn't have window pixmap or pbuffer bits set and only bind frame buffers to them, FBOs to them?
You wouldn't... yeah, I suppose so, it would be. Because you could still create a context from it.
Okay.
I don't think anyone's done that yet. It might confuse some applications, but these are probably new applications anyway. But you could support...
I've seen it once.
True.
Oh, okay.
But it broke the EGL spec in many other ways, so it's probably not should reference.
Yeah, I mean, these EGL configs could support EGL stream surfaces. So you do have one bit set in that array at least. It might still break the spec, I'm not sure, but that's the idea anyway. And you could still create Pbuffers, that wouldn't break the concept.
Right. Well, and then this is me forgetting the EGL spec. How do Pbuffer clobbers work in EGL if you don't have events, or do you not actually get to clobber them?
I don't remember how that works either.
Okay.
I don't know if we actually get that right or not either.
That seems entirely fair. Pbuffers are sort of awkward anyway.
Yeah, I know we get it wrong in X. No one's complained for as long as I've been in NVIDIA.
So how would you express the compatibility of... I have looked at the stream extension, but I don't have it in my head. How do you express the compatibility of a stream across multiple displays in this model? How would I be able to say I can sync this from source from here and sync to there?
Yeah, there's some hand-wavy stuff in the cross-process spec that says both EGL displays must be the same display or something like that. And there's no object to put in there and say this must be the same device. But what you really want is to say they must be on the same device. So really, you should probably go and amend that spec to say both EGL displays that you're using for this cross-process stream need to be on the same EGL device.
Or yeah.
So that's just one of the...
That if you have both these extensions, that's how the cross-process
right, like that's the interaction between the two.
Okay.
Do you even want to make the requirement that they end up on the same device? Because bumping them cross devices is kind of useful.
Yeah, so I would like the default to be that they have to be on the same device. And then if you want to do crazy cross-device splits and stuff like that, then you have to implement that yourself with another extension. So it's explicit to the application. They know when they're getting the blit. So I think that's better than making it invisible and saying, hey, how come this sometimes runs slow and sometimes it runs fast? Oh, it's because of blitz in there sometimes. So,
Guess.
So, just given an EGL device, how is the application expected to pick? Like, you pick FB configs on the grounds of I need this many bits of alpha, I need this many bits of Z. How am I supposed to know if I have wildly asymmetric GPUs in my machine because I'm just that kind of nerd, and I've got an R100 and a C islands? How do I know that I should pick one over the other because I need this set of features, or do I just pick it and then look at the EGL extension strings available and the configs available from it, and query the renderer that way? Is that the expected model, or is there something beyond that you want to decorate an EGL device with and say, query this device, give me identifier string?
Are you asking how you get two devices that are compatible, or how you just pick out a device based on your
How do I pick a
capabilities that you
device
want?
if I've got multiple and I'm an application, I want to pick the best one?
So I mean, the base spec only has one entry point saying this is an EGL device. Presumably there'd be other specs that would expose capabilities of devices, or maybe to start out you have to create an EGL display from each one and query their configs.
Yeah, I mean, that seems like a reasonable model of saying, well, I need to go create the display from the device and look at and inspect it that way. Because right now, right now what you have to do is you have to know about the Windows systems you might be running atop of and try to create an EGL display from them at all, and then hope that the types that you pass around into EGL create display are compatible. So the way that I guess that level of initialization is so not performance sensitive that there's not any that the setup overhead isn't that big, that there's no reason to want to query the device before you've created the display.
Yeah, it's not ideal though. You probably don't want every application to go initialize every GPU on the system and check all its capabilities, because that means loading every driver into the memory and everything.
Yeah.
So you probably want some layer to filter out above that and maybe drill down to that afterwards. I don't know. I don't really know what that is yet.
Okay. It doesn't seem like something that we need to have up front, though. It seems like something you could just add an entry point later for. This is how you query devices, and you'd have a platform extension that says I can hand this device in and query some caps out of it without having created a context and without having created the device or a display on it.
Right. I mean, right now we recently added the idea to EGL of having client extensions and display extensions.
Yeah.
So we could have another extension type called device extensions, and they could
Yeah.
be extensions that are queried from a device and have capabilities of devices rather than displays are the client.
Okay.
So, suppose you have a client running under an X server. That client queries how many EGL devices exist, and it detects that there's 2 EGL devices. What's the preferred way for that client to determine which device the X server is running onto? Should it attempt to create an EGL display with its X display through the normal channels, and then query the device of the resultant EGL display and do the comparisons, or are you expecting that normally client application shouldn't ever need to do this anyway? So why provide a mechanism to do it?
Yeah, I think that's how you'd have to do it. I mean, particularly because you might have a different device on each screen or something like that. And I don't know what other API would. I guess you could have something that queries something about the EGL device that you can also expose from an X extension. That seems like kind of overkill to me. You already have EGL doing that. It is the X extension that does that.
So just create the display, query for the device, do the comparison. That makes sense.
Yeah.
I don't think I have anything else.
Yeah. Okay.
It seems like it's got a lot of.
So, on Mesa Dev, we received some patches for mirror support a while back that we have been studiously ignoring because, we don't know how to test those patches. We don't know if they're correct. I don't know what to do with them. And I'm really looking forward to something like this arriving and becoming a reality, because then that patch set would be a moot point at that point.
Yeah.
Well,
Yeah. This is the debate I'd love not to be in. So.
So I'm curious for everyone else in the room. There hasn't been much discussion about the EGL output part, and that's one of the things we struggle with at NVIDIA as we look ahead to support all the alternate Windows systems. How should we expose display configurability for Weston, for Mir, and everything else? Should we be hooking into DRM KMS, and there may be advantages for that for other things like KMS Con, but I think there's some arguments in here for why you might want something more cross-platform, more standardized. We've got customers running on QNX and other environments that, the guys from Oracle, or if there's anyone from FreeBSD here, you comment on current state of DRM and DRM KMS there. So I'm curious on if anyone has opinions on the EGL output aspect of this.
Yeah. Also, in general, I honestly thought we'd have more angry people about new modes and APIs and stuff like that. So,
yeah, skip ahead a couple slides. One of the complaints that I had heard about the existing DRM API, the still existing DRM API, is that the existing interface down to the DRM already doesn't get down to the KMS part of DRM already doesn't give us the ability to accurately reflect what the hardware can do. That there are combinations of modes that look like they're all individually valid on outputs A, B, and C, and that in combination don't work. I can hit this on Ivy Bridge pretty trivially because it has 3 pipes, except it really doesn't. It has 3 pipes if you take half of the second one and split them into 2. So it seems, having tried to write an EGL screen surface just extension back 7 years ago now, we still haven't gotten anywhere near the mode setting API we want, even out of the kernel. So it seems a little bit strange to talk about writing that at the EGL level when we already don't have the API we want, period. We don't even know how to describe that today. We're already unwilling to say, well, we're just going to hand you back the permuted list of all the output mode combinations that are valid out from the DRM, and any way to set them all atomically so that the driver has any way of actually putting them all to the hardware at the same time. We already suck at that, and it seems a little bit premature. I would love to have mode setting be something that is portably reflectable, and I don't know if it's in EGL or in a different API, but we're already bad at it in KMS, and we're not making a whole lot of progress on it 7 years later.
There already is a Cronus mode setting API.
Yeah. I forget the name of it, but someone pointed me at that.
OpenWF.
Yeah.
Yeah, then if we could unmake OpenWF, that'd be great, but no one would notice. I guess part of the problem is sort of, admittedly, I'm on the Windows system side rather than the driver implementer side. So the advantages to me are a little bit less obvious, but it's kind of hard to see what advantage would come out compared to far be it from me to complement a popular mobile GPU vendor who has Sega Dreamcast heritage, but they do at least sort of slightly circumvent the problem by exposing basically their EGL backend as a set of vtables. So you can public API, you can drop in this new module which will implement a new Windows system for you. So I mean, it's definitely not the same thing at all, but it seems like that might be a slightly neater solution to the same problem you're making it not your problem, but you're not making it anyone else's problem either.
I think the DDK that you're referring to there is a good solution in many ways, but it works because there is also a bunch of libraries there available for you to allocate 2D buffers and pass around in a well-defined way. So you need that functionality standardized as well if you want to have this kind of extension point.
Yeah, like I said, we have some architecture roughly like that inside our driver anyway. The people in the company also say, what advantages does this have over releasing our, back-end API to the public? And the only real advantage it has over those is that it would be something standardized, so you can use it on all vendors. Yeah, I don't know. Has anyone tried to do that yet for that particular problem? I thought we switched over to the Windows, the EGL Windows System backends. But for mode setting, yes, I agree. I think it's hard. Maybe.
I think the I don't think there is a standardized way to have like a plug-in API for Windows systems, and it is a nice idea, but it does as I said require a whole lot of infrastructure like allocation libraries and mechanism to pass buffers and a mechanism to synchronize across processes and I mean I guess EDL Stream was invented to avoid exposing a lot of this, and I don't know, I don't have a good solution.
Yeah.
At least for sync and sharing, and this is Linux only, and you'll forgive me for not caring about the rest, but there is DMA buff import as an EGL image is at least promoted to EGLX now. So it's a start.
Yeah, I mean, a lot of people don't care about things besides Linux, but we have to at least. I don't know.
But the DMA buff import extension that gives you an image, I mean, it still doesn't really, it still doesn't really solve the problem, because EGL streams have the idea of a queue. We can do triple buffering using streams in some sort of transparent way, and images are quite dead, boring objects that can't do much with. Okay.
I guess one of the main problems I have with EGL image is that it's explicitly the types of the formats of it are hidden from EGL purposely. Whereas streams, you can actually create them with a config, or we've talked about other ways to create things without configs, but still specify the format for them. So, I mean, image could be a reasonable starting point if you had some way to go and specify the formats for it, but EGL stream already has that, and it already has the stream that most people want for their delivery of services between a client and a server anyway. So it just seems like a natural thing to use. Okay. Sounds like questions are winding down, so thanks, guys. And if you think about it some more and want to talk about it tomorrow, feel free to come over and talk to me or Andy, or Chad's talked a lot about it with me too on the Kronos meeting, so he might have some comments as well.